Here I'm going to look at some statistics. This is a Leaving Cert statistics question, came up in 2018, paper 2, question 2, and it has to do with z-scores. So we know the area to the left of z1 is 67%. What that means is the probability of finding a value less than z1 is 0.67. It means that 67% of the area lies to the left of z1, whereby the total area under the curve is 100%. Another way of looking at that is that the probability of any value being less than z1 is 0.67, because in total the probability of finding a value is 100%, but find the value that's specifically less than our z1 here. Well, we just look up the z-scores in the table, so we need to go across to our tables and find a z-score which gives us a value of 67%. That value of 6700 means 0.6700. As a percentage, that's 67%. So the z-score for that is 0.4, and to the second decimal place is 0.04. So in total, z value that gives 67% of the data is 0.44. So another way of looking at that is a z-score of 0.44 means that 67% of the data lies to the left of that z-score. Next question, the percentage of results in a maths exam for a class had a mean mark of 70, standard deviation of 15. Percentage results in an English exam for the same class had a mean of 72 with a standard deviation of 10. Here we're asked to compare two different data sets, and you're told that they were normally distributed. That means we can calculate the z-score fairly easily. We don't need to use a test statistic or sample distribution of the means or anything. We are literally just going to be able to work out a z-score. These are her two results. In which exam, relatively, did Mary do better? We're going to work out in maths her z-score. So the formula for this is in the tables, which is x minus mu over sigma. That's equal to z. So our z-score for maths is going to be individual value for maths, which she got 65, minus the mean for maths. The average in maths was 70 over 15. We know here that she obviously did worse than the average. That gives you results of minus 1/3. And in English, we have her result was 68. The mean was that bit better. Standard deviation was 10. That gives us a result of minus 1/5. What we have to do here is see which one is the bigger z-score. Minus 1/3, minus 2/5. So overall, that minus 1/3 is a bigger number than minus 2/5. Mary did better in maths. The z-score for maths is bigger than the z-score for English. Or minus 1/3 is greater than minus 2/5. In English, the top 15% of students scored an A grade, the least whole number mark that merited award of an A grade in English. So looking at that, basically is saying that the top 15%, saying that 15% are given an A grade. What we need to do is convert that 15% into a z-score. I'm going to use the formula z equals x minus mu over standard deviation. Work out the individual value there, x. So actually, what z corresponds to 15%? We want the value which comprises of z-score, which gives us 85%. Because when we look it up in the tables, we don't get the figure to the right of a z-score, we get the figure to the left of it. What we're looking up here is the probability that our z-score is greater than 1. To work out the value there in green, which is the 15%, actually have to work out the yellow percentage, which is 0.85. So we're going to go over to the tables, and I need to look up the closest number to 85. As you can see, it's here. This number here 0.8508 gives the z-score that represents 5% of the data. That z-score is 1.04. Z1 1.04, saying that's equal to x minus the average, and the average for English was 70 over the standard deviation, which is 10. We rearrange, so that's going to be 10 by 1.04 plus 72 gives us the result of 2.4. That's the score you needed to get in the test to make sure you were in this green bracket here. You needed to get 82.4, but considering they're all whole numbers, you actually needed to get 83 because that's what you're asked for. Using the empirical rule or otherwise, estimate the percentage of students in the class who score between 52 and 82 in the English test. This is 82 and this is 2. We're looking at percentage of students that are in between those two scores. You can use the empirical rule because that means that 68% of the people score between one standard deviation, etc., etc. So you can actually try to work that one out. The easy thing, I think, is just to convert both to z-scores. So we're going to say z1 is equal to 2 minus 72 over 10. So 10 over 10, which is 1. And z2 is 52 minus 72 over 10. That is 2. So essentially, if that's minus 2 as a z-score and that's 1 as a z-score, so we're looking for a value minus 2 and 1. That up, I'll get all the information to the left of a z-score of 1. Subtract information to the left of a z-score of minus 2, but I can look that up. All the information to the left of a z-score of minus 2 is the same as everything to the right of a z-score of 2. Let's look up the tables for this. Pz less than 1, that is here. 1 minus p less than 2 here. Percentage in between the two z values of 1 and minus 2 is going to be 0.8413, 1 minus 0.9772. Gives us a result of 0.8185, 81.85%. About 81-82% of the students in the class got between 52 and 82 in the English test.